Preparing for a system engineer interview? You've reached Candy Mentor, and this video is for you. We'll walk through 15 key questions you're likely to face. For each question, you'll see a sample answer, followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. Walk me through the Linux boot process. Where would you troubleshoot if a server fails to boot? A Linux system boots in stages. Firmware initializes hardware. The bootloader loads the kernel, and the kernel mounts the root file system. Then systemd starts services based on targets and dependencies. If boot fails, I check console logs, grub entries, init ramfs issues, disk UUID mismatches, and systemd emergency mode. I like explaining it as a chain: hardware, bootloader, kernel, init, services, because failures usually break one link. While answering, focus on BIOS or UEFI, bootloader, kernel initialization, init ramfs, systemd targets, logs, rescue mode, disk mount issues, and a structured troubleshooting flow. Question 2. A production server suddenly has 95% CPU usage. How would you troubleshoot it? I first confirm the symptom with top, htop, uptime, and vmstat. Then identify whether CPU is user, system, IO wait, or steal time. Next, I inspect the top processes, thread usage, recent deployments, logs, cron jobs, and traffic spikes. If customer impact is high, I mitigate by scaling, restarting safely, or throttling workload. After stabilization, I capture evidence and find the root cause instead of just killing the process. Make sure to cover triage commands identifying processes, user versus system CPU, recent deployments, logs, thread-level inspection, impact assessment, temporary mitigation, and root cause analysis. Question 3. Explain how DNS resolution works when a user accesses a website. DNS converts a domain name into an IP address. The client checks browser and OS cache first, then asks a recursive resolver. If needed, that resolver queries root servers, TLD servers, and finally the authoritative name server for records like AAAA, or CNAME. TTL controls caching duration. In real incidents, stale records, wrong CNAMEs, expired zones, or blocked UDP 53 can make an application look down even when servers are healthy. In your answer, talk about browser cache, OS resolver, recursive resolvers, root servers, TLD servers, authoritative DNS, record types, TTL, caching, and failure scenarios. Question 4. What is the difference between TCP and UDP, and when would you use each? TCP is connection-oriented and reliable. It uses a handshake, sequencing, acknowledgements, retransmissions, and congestion control, so it fits HTTP, SSH, databases, and file transfers. UDP is connectionless and faster because it avoids that overhead, but delivery and ordering are not guaranteed. I use UDP for DNS, VoIP, gaming, and streaming, where low latency matters more than perfect delivery. The key trade-off is reliability versus speed and simplicity. Be sure to mention connection-oriented versus connectionless behavior, reliability, ordering, retransmission, latency, congestion control, handshake overhead, and practical use cases like HTTP, SSH, DNS, and streaming. Question 5. How does a load balancer work, and what algorithms or help checks would you configure? A load balancer distributes client traffic across multiple back-end servers, so no single node becomes a bottleneck. At layer 4, it routes by IP and port. At layer 7, it can inspect HTTP paths, headers, or cookies. I configure health checks to remove bad instances automatically, choose algorithms like round-robin or least connections, and run load balancers redundantly. Sticky sessions are useful sometimes, but stateless backends scale better. While answering, cover layer 4 versus layer 7 balancing, round-robin, least connections, weighted routing, health checks, failover, sticky sessions, TLS termination, and avoiding single points of failure. Question 6. What are RAID levels, and how would you choose one for a critical server? RAID combines disks for performance, redundancy, or both. RAID 0 stripes data but has no protection. RAID 1 mirrors disks. RAID 5 and 6 provide parity, with RAID 6 tolerating 2 disk failures. RAID 10 gives strong performance and redundancy by combining mirroring and striping. For critical workloads, I usually prefer RAID 10 if budget allows. I also stress that RAID protects availability, not accidental deletion, corruption, or ransomware. Make sure to cover RAID 0, 1, 5, 6, 10, performance, redundancy, usable capacity, rebuild risk, hardware versus software RAID, and why RAID is not backup. Question 7. What is the difference between virtualization and containers from a system engineering perspective? Virtual machines emulate hardware and run full guest operating systems on a hypervisor. Containers share the host kernel and isolate processes using namespaces and C groups. That makes containers lighter, faster to start, and easier to package, while VMs provide stronger isolation and support different operating systems. I use VMs for hard multi-tenant boundaries and legacy workloads, containers for scalable application deployment. The operational choice depends on isolation, density, and manageability. In your answer, compare hypervisors, guest operating systems, kernel sharing, isolation, startup time, resource overhead, security boundaries, portability, and operational use cases. Question 8. What would you monitor on a Linux production server? And how would you define useful alerts? I monitor availability, latency, errors, and saturation, then map them to server metrics like CPU, memory, disk usage, inode usage, I/O wait, network errors, and service status. Good alerts are actionable, tied to user impact, and include context such as host, service, threshold, and runbook link. I avoid alerting on every spike. Dashboards help investigation, but alerts should wake someone only when intervention is likely needed. Be sure to mention golden signals, CPU, memory, disk, network, service health, logs, saturation, error rates, alert thresholds, noise reduction, dashboards, and actionable runbooks. Question 9. Describe how you would handle a production outage as the system engineer on call. During an outage, I focus first on impact and mitigation, not blame. I confirm symptoms, declare severity, communicate in an incident channel, and assign roles if the incident is large. I check recent changes, monitoring, logs, dependencies, and known failure modes. If a rollback or traffic shift is safest, I do that quickly. After recovery, I document the timeline, root cause, contributing factors, and concrete follow-up actions. While answering, focus on incident triage, severity assessment, communication, rollback, mitigation, evidence collection, escalation, timeline tracking, postmortems, and preventing repeat failures. Question 10. How would you design a backup and disaster recovery strategy for critical systems? I start by defining RPO and RTO with the business, how much data we can lose, and how fast we must recover. Then I design backups using snapshots, database dumps, offsite replication, encryption, and retention policies. For ransomware resilience, immutable or offline backups matter. The most overlooked step is restore testing. A backup strategy is only real if we regularly prove we can restore systems under pressure. Make sure to cover RPO, RTO, backup frequency, snapshots, offsite copies, encryption, retention, restore testing, immutable backups, disaster recovery drills, and prioritizing critical services. Question 11. How do Linux file permissions and ownership work, and how would you troubleshoot permission-denied errors? Linux permissions are based on owner, group, and others, each with read, write, and execute bits. For example, 750 means the owner has full access, the group can read and execute, and others have none. When troubleshooting permission denied, I check ownership, mode bits, parent directory execute permissions, ACLs, mount options, and SE Linux or AppArmor policies. I avoid using chmod 777 because it hides the issue and weakens security. In your answer, talk about users, groups, read-write-execute bits, numeric modes, ownership, ACLs, sudo, directory execute permission, SE Linux or AppArmor, and safe troubleshooting. Question 12. How would you automate server configuration across hundreds of machines? I would use configuration management instead of manual SSH changes. Tools like Ansible, Puppet, or Chef let me define desired state for packages, users, services, files, and system settings. The key property is idempotency. Running automation repeatedly should converge systems safely. I keep code in version control, test changes in staging, roll out gradually, and manage secrets securely. Automation reduces drift, improves auditability, and makes recovery much faster. Be sure to mention configuration management, idempotency, version control, templates, secrets handling, testing, inventory, rollout strategy, drift detection, and tools like Ansible, Puppet, or Chef. Question 13. How do you perform capacity planning for servers and infrastructure? Capacity planning starts with real measurements: CPU, memory, disk I/O, network throughput, request rates, and growth trends. I look at peak usage, seasonal patterns, and business forecasts, then define headroom so systems can absorb spikes and failures. Load testing helps identify which resource saturates first. I also set scaling thresholds and review them regularly. Good capacity planning balances reliability and cost instead of blindly over-provisioning. While answering, cover baseline usage, peak traffic, growth trends, headroom, bottleneck identification, load testing, business forecasts, cost trade-offs, scaling thresholds, and continuous review. Question 14. What steps would you take to harden a newly provisioned Linux server? I harden a new server by reducing its attack surface. First, I apply patches, remove unnecessary packages, disable unused services, and configure host firewalls. Then I secure SSH with key-based login, no root login, and limited access groups. I enforce least privilege through sudo, enable logging and monitoring, configure timesync, and run vulnerability scans. For sensitive systems, I add disk encryption and follow CIS benchmarks or internal baselines. Make sure to cover patching, minimal packages, SSH security, firewall rules, user access, sudo policy, logging, monitoring, vulnerability scanning, disk encryption, timesync, and CIS-style baselines. Question 15. Design a highly available web application infrastructure. What components would you include? I would place users behind DNS and redundant load balancers, then run stateless application servers across multiple availability zones. Sessions should be stored externally, usually in Redis or a database, so instances can be replaced freely. The database needs replication, backups, and a tested failover process. I add health checks, auto-scaling, monitoring, centralized logs, and alerting. High availability comes from removing single points of failure and regularly testing failover. In your answer, discuss DNS, load balancers, multiple availability zones, stateless app servers, databases, replication, caching, health checks, auto-scaling, monitoring, backups, and failure isolation. If you are still with us, congratulations, you are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.